So you can take a look at assignment 2. I think you can do the first 2 or 3 questions anyway, knowing what you know right now. Assignment 2 has you start to write a bunch of scripts. I'm going to show you how to make a script today. And then I think by the end of this lecture, you can finish up to the 4th question, I think, 4th-ish, somewhere around there. I don't think you'll be able to do the 5th question for a few days, for a few lectures yet, probably 2. But you can read ahead in the notebooks and find out how, if you want to finish the assignment early. I'm going to move the assignment due date a few days into the future because I was a little bit late posting the assignment. All right, so we were talking about creating bash scripts, so I should show you how to make a bash script. So a script is just a plain text file that contains a bunch of bash commands in it. So any way that you want to make a plain text file on your computer, that's where you begin. So I'm going to make that hello world script, which is already here. So I'm going to, oops, sorry. So that's, what's going on? Did I change the permissions on it? Yeah, I did. Okay, so change one. Okay, so this is this script that prints hello world. So I'm just going to redo this script, so I'm going to get rid of it. All right, and now you need to somehow create your script file. So if you're in Windows, you want to start in Linux, and then you want to start up some editor in Linux. So if you're in Windows, you're probably using Visual Studio Code, and so you can just type code, and away you go. It might do something like this the first time you run it. On my computer, it does it every time I run it. I don't know why. If you're on Mac, just pick whichever text editor you are happy with using on Mac, right? So if you're using Visual Studio Code on Mac, just start up Visual Studio Code on Mac. If you're using something like Sublime or something else, just start that up and everything will be fine. What do you think this is the license key for? I don't know. Get rid of it. I'm going to get rid of it. I hope I don't need it. Okay. What's this? All right. Don't save that either. Okay. So I'm now in code, and now you just make a file, right? So new text file, and then you start typing. So remember, every bash script should start with hashbang. So hashbang. The notebooks tell you to use bin bash, but I think you should probably use user bin bash. Sorry, user bin env. Come on. env bash like that. That will work on Mac and in Windows or Linux, I guess. Most standard Linux installations anyway. So you can write that. Remember that command, that first line just tells the shell what it should use to interpret the rest of the file. So the env program is going to look for bash, and the shell will use bash to interpret this file. In a second, I'll show you how to use something else. But for now, I'm going to use bash. And so I want to print hello world, so I want to print, so echo will print like that. Right, and once you're done that, you can save your file. Right, so, and hopefully I put this in the right place. That's not the right place. I knew that would happen. I'm just going to do it this way. Okay. So the reason I did it this way is because the other one started up in Windows. User bin env bash, and then echo hello world like that. Okay, and now I can just save it. So I've saved it. Right, and so there it is. Right, remember, if you try to run it, it's not going to work. So if I try to run it, right, doesn't work. It says permission denied. Why? Because, well, I don't have execute permission on hello.sh. So I need to make sure that I have execute permission on it. So u plus x, so give execute permission to the current user on hello.sh. Right, and now I have both read and execute permission on hello, so I can now run that. Right, and remember, we need the // to indicate that we want to run the file, the file hello.sh in the current directory. Right, because so remember again, the way that bash determines which program to run when you type in a command is that it looks in its path variable. Right? The path variable doesn't include your current directory, so we have to tell bash that the file that we want to run is in the current directory. Right? So the current directory separator, name of the file. Right? There you go. So that's how you would create a file from scratch. Or that's one way you can do it anyway. Right? And so those steps are right there. Okay, so we skip over all this. There's your, that's the standard first line of any bash script. Okay, so that shebang you can use for anything. So you can tell, you don't have to use bash to interpret this file, right? Well, in this course you should. But if you wanted to make your own shell script in some other programming language, you can, right? So for example, let me just go back to my shell. So suppose I want hello.py. So I want to write a Python script that will output hello world. Right? Well, I can just do hashbang user bin env Python. Hopefully Python on my computer. Might be Python 3. We'll find out in a second. And then I can just do print. Right? So now you can write a Python program that runs as a shell script. Right? Save that. ls. Right? Same rule. Right? I want to run this as though it were a command. It's a Python script, it's not a command, right? It's still a Python script, but I can treat it as though it were a command, but I need to make sure it has execute permission, or I have execute permission. So u plus x hello py, right? And now I can do hello.py. It's Python 3 on my computer, sorry. Probably. There you go, now it works. Right, and so you can pick whatever interpreted language that you want. Right? So Python is an interpreted language, and as long as you know the name of the interpreter, you can tell your shell to run that file as though it were a command. Right? You just change the first line here to indicate what interpreter do you want to use to interpret the rest of this file. So we're always using bash in this course, but now you know how to make a Python script and treat it as though it were a command. Okay. So you can put whatever you want into a bash script, right? Any sequence of bash commands, put it in the file, and that's your program, right? So there's the fortune command. We pipe the output to cowsay, right? We're going to use a moose to output the contents, right? If you save that as something, do I have it saved as something here? Fortune cow, right? We can run that now, right? And there you go. So there's your moose, right? Who's buried in Grant's tomb? A corpse. Right? And so any sequence of commands that you want, you can put it in your script and it will run in the order that they appear in your script. Unless you have a function, but we're going to talk about functions for like 4 weeks, 3 weeks. Okay, so the two scripts I've showed you so far are not super useful. One says hello world, one uses a moose to say something random. Right? Let's do something a little bit more useful. Okay, so the sequence of producing a bash script is a little tedious, right? Make a file, make sure you have the shebang line in, right? Enter the contents of your file, save it, make sure it's executable and readable, right? You can save yourself a few steps if you just make a little script that generates an empty file for you, an empty shell script for you, and sets the permissions on that script for you, and then you don't have to do all this. So here's a little script, right? What does it do? So it prints out. That looks like the first line of a bash script, right? I guess we should change this. So let me do user bin env bash, right? So that uses echo. It prints that out to the terminal. Now I have a redirect, right? So this will redirect to the file temp.sh. So it prints out that line, saves that line in temp.sh, right? And then we change the permissions on temp.sh so that the user has execute permission on them. I suppose if you wanted to be safe, you could put the R in, right? But almost everybody's Unix system is set up so that if you make a file, you also have read permission on the file. So typically you don't have to add read permission, but that's fine, right? So there's our script. And it's called make sh. So, right? So that, well, all right. So I mean, I changed it in the notebook, but basically it's the same thing here, right? It's the old version here, right? So now you can run this program, and there is temp.sh. Right, it has the correct permissions for me to treat it as though it were a program. Right, if I look at its contents, right, it's got the shebang in it, the first line in it. I forget what that line's actually called. Anyway, it's got the correct first line in it, and you're ready to go. Now you can just edit this file and save it as your own, and save it with the appropriate file name, and you don't have to remember to set its permissions or put in the first line by yourself anymore. Right, so there's an example of a little script that actually does something slightly useful. We verify it's created. Okay, that's fine. Okay, if you want to put comments in your script, you can. Right, so Bash's comments are exactly the same as Python's comments. Right, so you can use the hashtag to indicate the start of a line-ending comment. Right. Yeah, this is the hashtag, that's right. So not / like in Java, not / either, as in Java. Right. So the line-ending comment, the line-ending comment delimiter is the hashtag. Right. And so there's a little program. The name of the script is called comment.sh. Right? It has a second comment in it that says this program does nothing almost. Right? So if we run this program, if we look at this program, so I think it's just called comment. Yes. Right, there it is. Right? If you run it, not surprisingly, you get no output because there's no command in the script that generates any output. So it doesn't produce any output. Okay, so the rule in Unix is that every time you run a command, whether or not the command does anything, something does in fact happen. So the thing that happens is that the command produces what's called an exit code that the operating system receives. Right? So the exit code is just a non-negative integer number. So 0, 1, 2, 3, 4, 5. I believe in Unix it goes up to 128. Right? So those are the useful, quote unquote useful exit values. And so you can get the result, or you can look at the exit status of the most recent command by looking at the variable called question mark. So echo, now I need to get the value of this variable, right? The variable name is question mark. And so to get the value of any variable in Bash, you need the $, right? Question mark, right? And that says 0. So what that's telling you is that the result of running the last command, which was, oh wait, that was cat. Okay, sorry, hang on. The last command was cat. Okay, so that's the last command, right? It's 0. And so if a program or a command finishes without encountering any errors, then the normal thing to do is for the command to set the exit status to 0. If the command runs into something unusual, so produces an error of some kind, the normal thing to do is to set the exit status to some positive value, small positive value, right? You're not supposed to use values above 128, I believe. So 1, 2, 3, 4, 5, 6, 7, 8, and so on and so on and so forth, right? Other commands can use the exit status to determine if the previous command succeeded or failed, right? And if the documentation for the command is decent, you can even try to figure out what caused the problem by looking at the value of the exit status, right? You get an exit status of 3, that might have corresponded to some particular error, right? Versus an exit status of 1, which might have corresponded to some other error. Right, so if you look at the man pages or the help pages for some Linux commands, it will actually tell you what the exit status is if certain things happen. Okay, so every Unix command or every Linux command generates an exit status on exit. Right. Okay, so I called the question mark a variable. Technically, Bash doesn't actually call it a variable, which is funny. So what we call a variable, Bash calls a parameter. Right? So if you see anything in blue in the notebooks, it's giving you extra information. Right? So Bash calls a parameter some entity or object that stores a value. Right? And so to most of us, that just sounds like a variable. Why they call it a parameter, I don't know. Right? Oh, sorry, there's a distinction. So a variable is a parameter whose name starts with a letter. Right? So something that looks like a variable to most of us is called a variable. Right? something that resembles a variable but has a funny name is called a parameter, right? Or they're all parameters. So Bash actually uses the question mark as a parameter, right? So it will store the exit status in the parameter question mark, right? And so there are some symbols and some numbers that have special meaning to Bash, right? They're actually used as parameters, which is weird. So the numbers 0 through 9, actually, yeah, any integer number, actually, any non-negative integer number can be treated as a parameter, which is weird. I'll show you that a little bit later in the notebook. Okay, so remember, to get the value of a variable or a parameter, right, put the $ in front of the name of the variable or parameter. So if you ran that script, so there's running the comment script from inside Jupyter, right? If I want to know what was the exit status of that command, I can print out the value by looking at the value of question mark. What does it say? So between 1 and 255. Okay. So anyway, so I guess that's the range of standard exit statuses, right? So 0 if no error occurs, 1 through 255, I suppose, if an error or something unusual has occurred. You might wonder, how do you set the exit status of a script? Do I have true and false here? I don't. Okay, so let me edit. What do you think not comment is? Not. Oh, okay, fine. Okay, so if for some reason you want to explicitly set the exit status of your command, not surprisingly, the command that you would use is called exit. So I can do exit 1. That will stop the script from running. I guess more properly, it stops the interpreter from running the script, and it sets the exit status of the script to 1. Right? So now if I run comment and then look at the exit status, so $number, $? Question mark, now the exit status is 1. Right? So if you're writing a script and you detect an error of some kind and you would like to set the exit status, right, use the exit command to set the status. So this is still talking about comments. It's Bash comments are the line to ending variety. So you can put them after a command if you want to, right? Everything after the hashtag gets ignored. And so this is fine, right? If you wanted to edit the make sh script so that there was a little comment after the first line, that's fine. You can do it that way. Okay, so if you quote, of course, if you quote a hashtag, right? So remember, quoting takes away the special meaning of characters. So quoting the hashtag, of course, does not produce a comment, right? So that line there is not a comment, even though their hashtag is in it, right? It's quoted, special meaning of the hashtag disappears, and the hashtag just gets treated as a normal character in this case. Right? Okay, so comment always terminates a line, right? So you can't insert a comment into the middle of a line if you wanted to, right? So if you try to do something funny like this is called bad comment, right? So here I do ls, and then it looks like the original attempt was to list the file list all .txt files, right? And then oh, that should be a star there, I think that's what it's supposed to be, right? So ls star.txt, that's the command that the programmer initially wanted, right? They've inserted a comment into the middle of the line, presumably to indicate that this is listing all text files. That's not going to work, right? Bash sees the hashtag and it says everything else is a comment, so it's just going to run ls, right? And you get all of the files that are in the directory now. Okay. So that's comments, creating a simple script. Now, how do you give your script some input? Right? So the way you give your script some input is you can pass it some arguments, right, on the command line. And so there has to be a way for your script to actually access those command line arguments. Right? And so the way Bash does that is through these parameters called the positional parameters. right? They're positional parameters because they're numbered, right? And they're numbered 0, 1, 2, 3, and so on, right? So if your script, if someone runs your script and passes it 50 command line parameters, you now have 50 positional parameters, 51, 0, 1, 2, 3, 4, 5, up to 50, right? They're parameters, so if you want to get their value, you just put the $ in front of it, and that will give you the value of the parameter, except for the values 10 through 50. Anything bigger than 9, you have to do something special, which I'll show you in a second. Okay, so here's a little script called viewArgs. So this views the command line arguments passed to a script, right? If your script is accepting command line arguments, it might want to know how many command line arguments are there, right? How does the script know how many command line arguments there are? Well, there's a special parameter that stores that value too. The parameter hashtag stores the number of arguments passed to a script, right? So if I want the number of arguments, I can write $hashtag, right? If I want the value of the first parameter passed to the script, it's $1, right? $0 has a special meaning, which I'll show you in just a second, right? The second command line argument has the value $2, and so on and so on and so on. The 10th command line argument, if you want its value, you must write $, then the braces, and then the 10 inside of the braces, right? If you write $10, Bash thinks you want the first command line argument, $1, with a 0 stuck onto the end of it. Weird, but that's the way it works, right? So if you actually want the parameter 10, you need to put the 10 in braces and then slap the $ in front, right? You are not allowed to assign to any of the special parameters. All right, so you cannot assign hashtag, you can't assign 1, 2, 3, 4, 5, right? Any of the positional parameters yourself. Right. Okay, so this echo statement, there's a quote here, and then there's a new line, and then there's a new line after all of these lines, and there's a closing quote here. So it looks like this is going to print all of this out, each piece of information on its own separate line. It's a little bit easier to run this from the command prompt. Okay, so this is called viewArgs. Let me just check to make sure I haven't edited this file to do something funny. All right. So you run the program. So even if I pass in no arguments, the script doesn't crash, right? This is weird. So the number of arguments is 0, that's good, right? So what's the value of $0? It looks like it's sort of the name of the script. In fact, it's how the script was run, how it was invoked. So if I go up one directory, and I do introduction to bash scripting, viewArg0, right? So now it tells you that's how you ran the script, right? So command, the positional parameter 0 stores how was the script invoked, right? So it was run from that it was run from the directory above that directory, and that was the name of the script that was run, right? So that's what's stored in 0. Notice that the script ran happily even though there were no command line arguments, right? So there was no first command line argument. The script actually accesses the value that was in the first, that was supposed to be in the first command line argument, right? There wasn't one, but the script still runs successfully and produces reasonable output. Right? So if you access one of the parameters and the parameter doesn't exist, right? In this case, the value of $1 does not exist. There was no command line parameter, right? Bash replaces it with the empty string, right? It doesn't crash. It doesn't tell you there was an error of any kind. It doesn't tell you that $1 doesn't exist. Simply uses the empty string, and away it goes. Right? Same thing with 2, 3, 4, 5, 6, 7, 8, 9, 10, and it doesn't matter what positional parameter you try to access, it'll tell you it's the empty string, right? So beware of that. If you use a variable or parameter that has not been assigned to yet, Bash will create the variable for you and assign it the empty string. Will not tell you that there was an error. Yes?
If you try to assign one of them the empty string when you pass it in, will the number of arguments go up while keeping that?
Excellent question. So what if I run the command line, what if I run the program like that, right? So now I am passing in one command line argument, right? So now it tells you there's 1. 1 is the first positional, parameter 1 is still the empty string, but this time is because you said it was the empty string. Yes, so yes, it will assign that. It knows that you passed it in an extra another parameter. Okay, so let me go back to that directory so I don't have to keep on typing in the whole thing. Okay, so ABC, pass it in one parameter, right? The value of your first parameter is stored in 1, right? Pass it in 2 parameters, A, B, C, D, E, F, right? Stored in, the second parameter is now stored in 2. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? There are all 10 parameters. Okay, let me strip off the braces around the 10 to show you what happens if you do. Okay, so you have to, oh, sorry, no, that's fine. So you have to be a little bit careful if you need to access a positional parameter whose value is greater than 9, right? You have to remember to put the braces. So if you don't, you get something weird. I'm not gonna run this one because it's gonna, the output will be deceiving. So I'm gonna pass in 99 as the 10th parameter, right? Why is that still 10? Oh, wait, I edited the script wrong, sorry. Should be,
because it's 1 plus the 0.
No, I ran it here. 1, 2, 3, 4, 5, 6. Oh yes, yes, that's right. Thank you. That's exactly right. Right. So the output here is deceiving, right? Thank you. Let me run it a different way. Thank you. That explains it. Okay, there. I want to change the 1. Okay, so now you get 99 and a 0, right? So what the heck happened here? You got the value of positional parameter 1, which was 99, and then we stuck a 0 onto the end of it. Right? So here, sorry, that's hard to read because of the coloring, right? So if you write $1, it doesn't matter what you put after it, right? Bash thinks that you want the value of positional parameter 1, which in this case was 99, right? So it replaces the value of $1 with 99. And then it slaps a 0 on the end of it, so you get 990. Right, so if you want the 10th parameter, or any parameter who's, that's got more than 1 digit in it, you need to wrap the name of the parameter in braces. Right, to disambiguate disambiguate the name of the parameter. Okay. So if you are strictly working in Jupyter, and I recommend you don't strictly work in Jupyter, there's no way for you to call a script in a Jupyter's notebook cell and pass that notebook cell parameters, right? So if you want to write any script that needs parameters, you have to write the script. You can't save it in a Jupyter notebook cell and call the notebook cell. That's not going to work. Okay, so here it emphasizes it's not an error to attempt to obtain the value of a parameter that is not set. Right? You simply get the empty string for the value of the parameter, and no error is indicated by bash. Right? So the notebook encourages you to play around with view args and see what happens if you run it. Okay, so now that we know how to get the value of a command line parameter, right, we can now start to do more interesting things, right? So our hello world program printed out hello world. It would be nice if we could greet the user instead, right? And so we can write hello you, right? Where it prints out hello and then whatever was the first command line argument, right? Right, so the first command line argument is $1 or $brace1, it doesn't matter in this case. Right, so dot hello you. Right, with nothing prints out hello, comma, nothing, right? Oops, sorry, there's nothing here, right? And sorry, hello, comma, space, nothing, and then the exclamation mark, right? Hello, sys220, prints out hello, sys220, right? Okay, arguably still not super useful, right? But we had that make shell script from earlier, right? And it would save everything to temp.sh, right? Why not save it to another script of your, why not save it to a script with whose name is specified by the user when they run the script, right? So named sh will create a named empty shell script for you. So dot named right? My script. Right, and there is my script. Right, it's got read and execute permissions on it. If you look at the content, I guess I should have said my script.sh, but that's fine. Right, it's just an empty script with the first line of the script already there for you. Right. Okay, what happens if you run my script with no argument? Right. Oh, so now you get an error. Right. Why do you get an error? Go back and look at the script. Right. So if you call named sh with no argument, then the value of 1 is the empty string. So this tries to do a redirection to nothing, which doesn't work in bash. Right. So that's what it's complaining about here. Right. Ambiguous redirect. So it doesn't know where do you want to redirect the contents of the file. So this might be okay for this script, right? You might be satisfied with this error output. Probably not. You might want to make it look a little prettier. There's some other funny things with this script though. So there's some things you really have to watch out for. Right. So if your script is taking in a parameter, a command line argument that corresponds to the name of a file, which this one is, right? You have to be super careful about what you do. So for example, suppose someone creates a script whose name is my space script.sh, right? In Unix, this is a perfectly acceptable file name, right? You are allowed to put spaces in a file name. You probably shouldn't, but it's perfectly acceptable, right? Okay, so you run your program, right? And again, you get the ambiguous redirect error, which is strange, right? Do we get any output? We don't. Okay, so that's good, right? And so now you say, well, what the heck's going on here, right? Is my script broken? What if I take away the space? No, everything's fine, right? There's my script.sh. So the space is where, even though I've quoted the space, something weird has happened, right? So what the heck has happened, right? So what's the value of $1? It's my space script.sh, right? So you're trying to redirect to now two things, right? You're trying to redirect to the file named my, right? There's a space in the string, so bash performs word splitting, and now it sees a second value after my, right? Script.sh, and you cannot redirect to two files at the same time. So again, so bash, whoops, complains again, right? Ambiguous redirect. It even tells you here, cannot access my, right? Cannot access script.sh, right? No such file or directory. So what is the solution? Right? You have to prevent word splitting from happening, right? How do I do that? You have to quote the $1 in this case. Right? So when I do the redirect, right, I need to quote. Shh. Right? Run that. Oh wait, hang on. Let me nuke the scripts I created. Seems to work. You look at your output, right? Oh wait, sorry. I need the space. There we go. Okay, so run that, and now ChangeMod is complaining, right? Cannot access my, right? It complains a second time. Cannot access script.sh. What's the problem? It's the exact same problem as before. Right? The value of $1 is my space script.sh. So ChangeMod thinks you're trying to change the permissions of two separate files. Solution, you have to quote the $1. Right? Right? So there it's quoted, there it's quoted. Come on. There. Okay, everybody's happy now, right? And if you look here, there is in fact a file named myscript.sh, and it has the correct permissions here, right? So whenever you use the value of a variable, right, you have to ask yourself, right, do I need to quote this thing, right? Does it have any special characters in it? If it's a file name, you almost certainly have to quote it, right? That is used to produce a file name. You probably have to quote it here, right? All right, so that's the introduction to shell scripting lecture. Anybody have any questions about what's going on here? Okay. Next topic, variables. So you can't write any non-trivial program without, oh, that's not exactly true. You can't, it's difficult to write a non-trivial program without using variables of some kind, right? So in Bash, a variable is a parameter, right? So it's a parameter that has a name starting with a letter. You can use letters, numbers, underscores in a variable or parameter name, right? So a word consists solely of letters, numbers, and underscores, and the beginning with a letter or underscore. So you can't start a variable name with a number, right? And so when you're naming your variables, right, just name them the way you do them in Python or Java, right? Use letters and numbers, everything will be fine. I don't think Bash lets you use the symbols as your own variable names. So I don't think you can use a parameter as a variable name. Okay, so the second, I guess the most important thing that you have to remember is that in Bash, the variables are untyped. Everything is a string as far as Bash is concerned, right? So that's basically the only type that Bash works with. Depending on the context, you can convince Bash to treat a string as though it were an integer, right? So in other words, it contains only digits, right? So basically, if you're trying to do arithmetic or some kind of numerical comparison, Bash will interpret a string as though it were an integer. There are no floating point values, so you can't use any decimal values in your Bash scripts. If you need to, you have to call some other command that knows how to treat or knows how to deal with floating point values. Right? So Bash itself, basically, it wants strings. It's dealing with strings. Right? So there's no syntax, no special syntax for declaring a variable name. Right? So in Java, you've got to say type space name before you use it. Right? In Bash, you just create the variable when you want to use it and give it a name, right? Bash creates the variable and gives it a value if you also do an assignment to it, right? So the assignment operator in Bash is the equal sign, right? No space around the equal sign, right? Remember that, you can't put spaces around it. You end up with word splitting and then bad things, and then unusual things happen, right? So a, no space equals no space 2 means make the variable a, give it the value 2. Right? It's actually the string 2, it's not the number 2 here. Right? B equals some string, works just fine. Right? You have to quote the sum string in this case, because if you don't, right, it sees the space and it thinks B is equal to sum, and then there's some strange, I think it interprets B equals sum as though it were the name of a command. So it tries to run that command with the argument string. And so again, unusual things happen. Right? String concatenation. So if I got A and B already, right? So A and B have a value, I can do $A, $B. Actually, I lie. You can do $A, $B anytime you want, and it will work. It just won't give you what you think it should give you. Right? So I'll show you that in just a second. Right? So here, this is a parameter expansion. Right? So whenever you ask for the value of a variable, right? Bash replaces the $variable name with the value of the variable. Right? So that $A gets replaced with a 2. Right? That $B gets replaced with some string. And so C becomes 2 some space string, all quoted. Right? When you do an assignment, you don't have to quote. So if you're doing a simple assignment like this, for example, you don't have to quote the $B in this case. Right? So in a simple assignment, the quoting doesn't normally matter. If you have a more complicated assignment, the quoting might matter depending on what it is exactly that you're writing. Right, so if you run this, no complaints, right? And if you print out the value of C, you do in fact get 2 some space string. Right? Now if I go over to my terminal and I do echo $A and I do echo $B, okay, if you have a variable, you can use the command called unset. So unset A will remove A as a variable, right? Yeah, okay. So it effectively removes a as being a variable, and unset b effectively removes b as a variable, right? Now, if I do c equals $A, $B, right, your bash does not complain, right? So here, I'm making a variable c, I'm assigning it the value of a concatenated with the value of b, right? A and b don't exist, bash doesn't care, right? It makes the variable a for you, sets it to the empty string, it makes the variable b for you, sets it to the empty string, and now you get c is equal to the empty string. Right? So nothing gets printed out here. There is nothing here. Whoops, sorry. Right, there is in fact nothing here. And so this works. It doesn't, bash doesn't tell you or warn you that you might have done something that you didn't mean to. Right? So it doesn't say, hey, A doesn't exist. It doesn't say B doesn't exist. Right? It assumes what you typed in was what you meant, fills in a value of A and B for you. Right? And so one of the very difficult things in writing a bash script is getting used to the fact that if you use a variable name and that variable doesn't already exist or isn't set, bash is going to make it up for you and set it to the empty string, and it won't tell you that there's a problem. Right? And so your script will appear to run, it's going to run with the value of the empty string instead of the variable that you meant. Right? This is especially problematic if you're still using very long variable names and you misspell it once. Right? Because the misspelled variable name will now become the empty string and your script will run, but you won't get the results you expected. Now you have to debug the thing. Right? So be very careful about that. Right? Okay, so if you want the value of a variable, right? Notice on the left-hand side you never write $ something, right? On the left-hand side is the name of the variable, right? On the right-hand side of the assignment sign, you probably want the value of the variable, so $ variable name, right? Most of the time you can get away with writing $ variable name. Occasionally, you have to write $brace variable name, right? And so you have to use this form if you're doing one of the special parameter expansions that the rest of this notebook talks about, right? And occasionally you have to use this form if you're trying to do something with an underscore. Right, so I'll explain that in just a second. All right, now you might wonder, look, you taught me Java, you taught me Python, this $ nonsense didn't show up in those programming languages. Why is it showing up here, right? So why do I need this $sign in order to get the value of a variable, right? Why can't I just write A equals C, right? So remember that the shell, as far as the shell is concerned, everything's a string. So when you write A equals C, it doesn't know, do you mean the variable C or do you mean the string C, right? So you have to disambiguate it, right? So if you want the value of the variable, you need the $sign in front of it. So $A equals $C means give me the value of C, right? Don't give me the character C or the string C. Right. Okay, so, right. This shell also defines a bunch of variables. I don't remember how many it defines. There are a bunch of special variables that are also defined by the shell. Right? One of them is user. So the variable user stores the current username. Right? So if you print this, run this, it says welcome user. So big user is not the current username. Right? User is a variable. If I want the actual username, I need the $sign in front of it. Right? So if I run this, it's going to print something like, yes, welcome Burton. Right? So if you're in a script and you need the user's current name, you can use $user. If you want their home directory, your home directory is $home. Sorry. Right, so home, the variable home, stores the location of your home directory. Right, you might ask, hey, why do I have to use $home? Why can't I use tilde? Right, because you told me there's a tilde expansion, and this prints out your home directory is tilde, which is not particularly useful. Right, remember that inside double quotes, tilde expansion doesn't happen. So if you need the value of your home directory inside of a quoted string, you need to use a variable. Right, so sorry. dollar home, like that, right? So also notice that inside double quotes, parameter expansion still happens, right? This thing's double quoted, right? That's an expansion, right? Usually quoting turns off, quoting turns off some of the expansions. One of the ones it does not turn off is the parameter expansion, right? So parameter expansion still happens inside double quotes, right? Also remember, single quotes turns off everything. So, oops, sorry. Oh, there. Single quotes turns off everything. So if you single quote that string, you get dollar message, your home directory is dollar home, which is probably not what you wanted here, right? Okay, so when you ask for the value of a variable with the $, that's called parameter expansion, right? Or variable expansion in Bash, right? So the expression C equals $A, $B contains two separate variable expansions, right? One for $A, one for $B, right? Whatever the value of $A is, it just gets inserted here. Whatever the value of $B is, it just gets inserted here. String concatenation appears, and C is some string. Right? Okay, so you can always use $brace variable name. That will always work. Most of the time, programmers will not use the braced form, so they just write $variable name because it's easier to type. Every once in a while, you will get into trouble if you don't right here. Yeah. Okay, so here's an example of a script that's using parameter expansion, and it's called bad backup for reasons that will be clear in just a second. Right. So this script, it looks like it looks at the first command line argument, right? Calls that and stores that in the variable in, right? It creates a string, so it looks like it's the value of in. Right, followed by an underscore .bak. So if I pass this a file name, say file.txt, it looks like out is supposed to be file.txt underscore .back. Right, so what the thing's doing is it's trying to make a backup of a file in your directory. Right, and then it uses copy, right, to copy the input file to the desired output file. Everything's quoted, so this looks like everything should work. Right. If you try to run this file, or run this program. Okay, so where's, it's not here, sorry. Over here. Is this going to be in the right directory now? No, still the wrong directory, sorry. Bad back. How do I, oh, there again. Okay, so make sure I have read and execute permission on that file I just made. Okay, so I'm gonna make a backup of hello.sh. I'm expecting to get a file hello.sh underscore .bak. Right, and if I look at my directory, I end up with, what do I end up with? Oh, I end up with a .bak, which is weird, right? There is no hello sh underscore .bak, right? I got a .bak instead. What's in .bak? Well, it is the contents of hello.sh, so it looks like we backed up our file to a funny file name. So what the heck happened here, right? And so this is one of the circumstances where you must put your variable name in braces, right? The underscore is a legal character in a variable name. So when Bash sees $in underscore, right, it thinks you want the value of the variable in underscore, right? The period's not a valid character in a variable name. right? So it doesn't try to interpret in underscore dot as a variable name, right? So it tries to interpret that as asking for the value of the variable in underscore, right? Now, that variable doesn't exist in my script. So bash makes the variable in underscore, gives it the value, the empty string, and out is just dot back. So when you copy your input file, it copies it to the file .bak, right? And so this fails. So this is the case where you have to disambiguate the variable name, right? I don't want the variable in underscore, I want the value of the variable in, right? And so now if you do that and if you change the script, it'll work, right? So that's the one circumstance I'm aware of where you might have to put your variable name inside of braces, right? If you need more explanation of that, the notebook does explain in detail exactly what's going on, right? And it tells you the solution as well. All right, that's enough for today. I'll see you next week.